Assalamualaikum everyone. Welcome to the first class of micro manufacturing technology. So today we are going to have the introduction to the micro manufacturing technology. Okay, there will be several topics that we're going to cover for this class. Here are some topics that we're going to cover today. For example, what is micro manufacturing and the concept of and trend of miniaturization, and then why micro manufacturing is important. So the difference of conventional to micro manufacturing processes, and what will be the future of micro manufacturing, and also the introduction to the nanotechnology. So this is a picture of an ant under the microscope, okay, under the SEM. So if you can see on the left side of the ant, there's a gear here, okay. So this gear is produced via the micro manufacturing processes, so that you can imagine how small is the product that can be produced via the micro manufacturing processes, okay. So let's see the processes that involve in here. So before we go further, what is micro manufacturing? So as it is named as micro manufacturing, it represents the manufacturing of component or devices or any parts in micro scale. So that's it. What is micro manufacturing? So we're looking into the trend in micro manufacturing. So I'm not sure from which generation you are in this computer version. As for me, I start with this one. I'm the first computer that I have at home is like this one, and then we move into the flat screen, and then to the laptops, to the notebook, and now we have tablets, and we don't know yet what is next in this trend in the micro manufacturing. The same like the computer, the evolution of the telephone also shows the same pattern. Okay, so you're seeing the trend and evolution of the telephone right here from this kind of telephone. I'm not able to see this type. I think I start with this one. Okay, I'm also able to see the handphone like this one owned by my mother. Okay, so right now we are moving into smaller things, right? What will be the other things that you can see from this one? What will be other than size? What is the other things that we can see from this evolution? Based on the trend that we see in the computer and the evolution of the telephone, we can see the first thing is of course the size become very small, like, and also stronger compared to the previous one. And then the second one is into the function. If you can see, the function will become much more compared to the previous version of the telephone or computer. If you can see, uh, previously telephone is just used for calling, but now we are using the smartphone where you can look into movies, you can browse into the internet and everything. So there are value added into this system, and of course it's higher in terms of the performance, higher reliability, but less power usage and expense. So in this world, we are looking into the miniaturization trend in the market. So what is miniaturization? It is a trend where we want to manufacture even smaller things from mechanical, optical, electronics products and devices. For example, uh, miniaturization of mobile phones, computer and vehicle engine that going downsize into smaller size and much lighter compared to the previous one. That is what is called as miniaturization. So if you want to see into the size of the micro product, so it can varies from 1 mm to 2 mm, and it goes till the 100 micrometer. So if this you see this one, it is not seen by the our naked eyes. We cannot see this one under naked eyes. It has to be look into the SEM or special microscope so that we will be able to see the size. If you can see here, this is 100 micrometer, which is very small. Now let us look why micromanufacturing and nanotechnology is important. To look how important is micromanufacturing, you can see into this graph. This is the top spender on the R&D, okay, the manufacturer that spend on the R&D. So the top two is Amazon and Alphabet, but if you can see the number 3, number 4, and number 5 is the micro manufacturing company, okay, company that produce part with micro manufacturing processes. Okay, so this is showing that when people spending so much money in this business, meaning it is going to expand more and more in the future. So this one is in 2018. Now we are in 2021. So imagine how big is the market for the micro manufacturing. So now let us see the difference between conventional and micro manufacturing. So the answer for this one is all about the size. Okay, so this one is showing the table on the wavelength of radiation and also the manufacturing processes. So in the micro manufacturing, X-ray and ultraviolet will be used in the process, which is the what we call as lithography processes. This one is used to print the circuit on the micro product, especially the circuit for the chips. Okay, so as for the manufacturing processes, the process is much more going into the upper than the micrometer. So if you can see, the micro drilling is here, and this one is the conventional machining. So this one is the micro manufacturing is still involved until here, but for the conventional machining, it goes from the and above. Okay, so but for the micro manufacturing, it composed of the going further into the atomic size of machining. So in terms of the comparison, if you want to compare in terms of the feature size of the work material, it can goes up to the 1 meter or even more, even bigger for the conventional machining. And then for micro machining, it can goes to mm to sub mm, meaning that smaller than the mm itself. And then for the molecular manufacturing, it can go to beyond to 100 nanometer. So this one is more into the nanotechnology. Okay, so in terms of the accuracy, for the conventional, it can goes up to 1 mm. It cannot go further. Okay, so but for the micro machining, it can goes to the sub micrometer, and for the molecular manufacturing, it goes up to 0.0 go down to 0.3 nanometer. Okay, so as for the conventional machining, usually the surface roughness is measured in micron. Okay, if you do the machining, so we measure with RA, right, the value usually in micrometer. Okay, so for the micro machining, the surface roughness can be measured up till 10 to 20 nanometer, but not for the molecular manufacturing. Why we are not able to calculate the average surface finish? Because it can goes up to 1 atom size. So there is no device that will be able to measure that surface, that kind of surface roughness. Okay, so so this one, for the conventional and micro, we still have the material and shapes. Okay, for both of this type of processes, but for the molecular manufacturing, meaning the nano machining, it goes to atom and bond instead of the material and the shape. Okay, I include also here a link for the for you to see you can look into how small is the micro product actually. If we can see from here, you'll be able to see how small is the micro product.